really considering that structural engineering job with Dowdy up in, yeah, he's working.
We can't go wrong with a structural engineering job.
Yeah, and it's in Allen, DC. It's a good location.
That's not bad. That's not bad. All right, let's get started. I'm going to pause the recording here in a second, and you'll see why. I want to make sure everybody is on the same page, and everybody is aware of all the materials available for the class and whatnot, and just some general housekeeping. All right, everybody, 7. So first off, you all know I'm canceling class on Wednesday, January 23rd. I want to talk a little bit about Blackboard because I've done some updating and some posting to Blackboard. So let's see. If I go to Blackboard, let me pause the recording and you'll see why I'm on. All right, so we're back. Okay, so today, like I said, what I want to talk about today is I want to talk about cost estimation techniques. To be honest, two things. I really don't know where everybody's at on this topic. I mean, I know some folks are going to be stronger at this than others. And I've been doing, senior design for a while now. And if there's any one technical aspect of the project that always needs improvement or always needs work, it's the cost estimation. Usually when it's all said and done, if we do a bridge project, usually the bridge design is actually pretty good at the end of the day. And then it's, $20,000 or it's $800,000. Neither of those two numbers are right, okay? It's somewhere in between. But that was a joke. So that tells me I'm happy I'm doing this lecture. So what I want to do today is I want to go into just some basics of fundamental cost estimation and just some things that I think you need to be aware of. Now, I'm going to be honest, when I get started and I start talking about cost estimation, it's going to get real basic real quick. I don't do this to sort of, I'm not like trying to belittle anybody's intelligence or anything, but I want to start at square one and then sort of work my way up. So in a very rapid pace, you'll see how we go from something very simple to something that can get very intricate very quickly. So what I'm going to be talking about is just the general idea behind cost estimation. I'm getting this out of the way. And then I'll talk about cost indexing. How many of you have heard of cost indexing? Okay, so some of you have, some of you haven't. Okay, so that's good. Specifically, we'll look at historical cost indexing and city cost indexing, which is basically trying to normalize your prices with respect to location and with respect to time. And then look at some preliminary cost estimation, some detailed cost estimation, and just sort of so you can see where I'm coming from in terms of what you need to prepare for your senior design project. So let's just start at the basic beginning. Let's talk about the introduction, basics of cost estimation, talk about some available resources. Okay, so one of the most fundamental tasks in a construction project is the estimate, how much it's going to cost. As you know, in this course, let's say we're working on a bridge project, during the alternatives phase, you will need to prepare multiple different alternative designs. And you have to make a selection why you're going with this project as opposed to this one. There's a number of different reasons. Let's be clear. There's a number of different reasons beyond cost as to why you would go with, let's say, a concrete bridge versus a steel bridge. For example, if we were in, let's say, Arizona, we'd be having a completely different discussion just because the availability of steel, let's say in Arizona, is just not the same as it is here in West Virginia. That's just is what it is. But here, Huntington Steel's right down the road, so we have more options. So I don't want you to think that just the dollar figure at the end of the day is the be-all, end-all final decision maker. It isn't, but it's a big one. If I have two options and one costs $300,000 at the end of the day and one costs $500,000 at the end of the day, and every other conceivable parameter, transportation, transporting girders and labor requirements, everything else is identical, I'm going to go with the cheaper project. So I want you to understand how this works. Now, when I say cost estimation, I'm talking about more than just raw material costs, like the cost of the structural steel, the cost of the concrete. I'm talking about equipment costs, rental of, cranes and earth moving equipment and things like that. I'm talking about maintenance costs. I'm talking about labor. I'm talking about engineering costs, support personnel costs. If you're an engineering firm working on a project, engineering firms, they do kind of like to get paid, so you need to pay them too. We're talking about overhead. We're talking about operating expenses. We're talking about profit at the end of the day. So there's a lot going on here, and so I want you to sort of be aware of what I'm talking about. Now, I want to also be clear that in the real world, by and large, the absolute best resource for determining accurate cost estimation is your company or your firm. Okay? If you work at a company that's been doing, let's say pre-stressed concrete short span bridge design for the past 40 years, they're going to have far better resources, in order to determine how much that, a given project's going to cost than, quite frankly, I am or any of us are, because, they've been doing this for 40 years. They probably know the industry, like the back of their hand. They know the economics and the economy of the surrounding area like the back of their hand, and they're just going to have better tools than the general populace is. So, the most accurate data to price a project is going to come from historical information with your company. I want that to be said right off the bat. Now, in lieu of this, there are a number of resources that are available to you. For instance, supplier catalogs. For instance, if you were trying to estimate the cost of, let's say, this building, well, you start breaking it down into individual components. So let's say the desks and the chairs. How much do you think those cost? You want to know what I would do? I would call the company that manufactures them and say, how much did these cost? That's going to be probably one of the best sources. Now, in lieu of that information, I could probably find generic information. Well, how much do desks and tables in common university classrooms cost? And then use that. It's going to get, my accuracy is going to get lower and lower the farther I go, but that doesn't mean the resources are non-existent. I want to introduce you to probably one of the most common construction cost data resources that are available, and that's RSMeans. I'm curious, how many of you have heard of RSMeans? You've heard of that, so I got a couple. RSMeans is basically an organization that compiles just about every single construction cost component that you can think of. I mean, they have boatloads of these different guides that basically list cost data of various components in a construction project. And it goes from earthwork to landscaping to site layout to how much the light switches cost to how much the cost per square foot of carpet. I mean, everything. They have labor costs. I mean, here in the back they have costs of how much does a steelworking crew cost per hour? How much does a bricklaying crew per hour cost? I mean, I mean anything and everything that you can think of. I want to pass this around and I want y'all to sort of flip through it. I have about 5 or 6 of these on the cart outside my office. We're going to talk about logistics, about how we handle that later, because I know in some years there's been instances where like Team 2 just has the RSMean guides all semester, and then Team 3 is like, how are we supposed to do a cost estimate? We don't have them. So we'll have to discuss logistics later. But I do want everybody to have a good look at it, passing it around. Yes, sir?
Here's a question. So is it kind of adjust itself for the region that you're in? It feels, some places it might be more, some places it might be less.
Oh, I'm getting to that. Oh, that is a great question. That is a wonderful question. It's almost like you were a plant in the audience, and I pulled, yeah, I pulled you aside before class started. I said, could you ask this question? That's a brilliant question, because we are going to get to that here in a second. Okay, don't worry. Okay, let's take it down to cost estimation 101. Okay, the most fundamental equation in cost estimation is the unit price equation. That the cost of a given unit is the unit price times the number of units. So, an example. How much does 12 linear feet of a W10 by 49 cost if the unit price is $60 per linear foot? Like I said, we're starting at square one. Okay? So if it's $60 a foot and it's 12 feet, 60 times 12, that's 720 bucks. That's pretty easy, right? That's not bad. Okay. Any questions on that? Okay, good. Now, so that's pretty basic. Okay. Now here's an example of just some of the data that's reported in RSMeans, because really the way RSMeans and the way cost estimation is going to work is this. So for instance, if you're designing a bridge, if you know how much the girder costs per foot and you know how long the girder is, well, there's your cost. So the big question is, well, how much does the girder cost per foot? That's where RSMeans comes into play. So for instance, as this gets passed around, you're going to see it's just oodles and oodles of tables like this. This is a concrete, or a CMU, like a concrete masonry unit table. So for instance, if I have concrete backup block, let's say 6 inches thick, there's a couple things. So crew, so here it says crew D8. That's the work crew that would be used to build this component in a structural system. The back of the book lists all sorts of crews, like crew B1, crew C13. There's just oodles and oodles of crews for different types of jobs. The rates, the workers, the equipment required, let's say for bricklaying, is going to be different than for ironworking and what have you. The daily output says how many units this crew can produce in a given day. The labor hours is, the book uses the term labor hours. If you've heard the term man hours, labor hours, essentially the same thing. This is how many labor hours is required to produce a single unit. The units, so like what units are we talking about? We're talking about SF. What do you think SF stands for? Square feet. So this is square feet, essentially, of wall. So the 2007 bare cost, so it's $1.98 per square foot, $3.19 per square foot in labor. Total, including overhead and profit, would be $7 a square foot. So you can see where a lot of this is coming from. The guide assumes a 10% profit margin, so that you can change that if you would like, but that's just something to keep in mind. Everybody good so far? Okay. Now, one thing that's kind of crazy, and I know this might seem a little weird, but as you delve into this cost data, one thing that's kind of weird is what are the units being used. I mean, some of these are some really out there units. So let's see. Let me see. So some of them are pretty straightforward. So some of them are listed in units, like if you're talking about electricity, in units of amps or amperes. But then you have units of chilled water, ditto. Let's see, dry film thickness. I probably wouldn't have thought of that, or some of these. So I have a link here, and this link is available in the PDF that's online. And basically, it pulls up this sheet and a few others. So if you're looking it up and it says LF, what is LF? Well, LF stands for linear feet and whatnot. So ACRE, acre, all that stuff. Okay, sound good? Okay. Now, let's talk about cost indexing, okay? Have you ever heard of a cost index, or maybe heard of a consumer price index? Have you ever heard that term before? If you're not sure what that means, there's a really easy way to explain it. Have you ever had, let's say, an older relative or a grandparent come up to you and say something akin to, back in my day, a Coke cost a nickel? You ever heard a phrase like that before? Or back in my day, gasoline was less than $1 a gallon. Everybody's like, well, that would be okay with us right now, right? Okay. So I know a lot of times you like to think, well, this is just inflation. Well, don't get me wrong, inflation has a key to play in this, but it's not just inflation. There's improvements in technology. There's all sorts of different components that can play into what's called the Consumer Price Index. Now, the Consumer Price Index is a value. Anybody, you can look that up on Google. It's pretty easily, and it's basically a dimensionless quantity that sort of expresses how expensive stuff is at any given point in time. So generally, the Consumer Price Index now is less than the Consumer Price Index was, let's say, back in the 80s. Back in the 80s, a a can of Pepsi costs just less than it does today, okay? And that's just because over time the cost of goods and services goes up. It just is what it is. The reason why I bring this up is because that trend is not just prevalent in purchasing, a can of Pepsi from a gas station. We're talking about, does this affect the price of 2x4s, or does this affect the price of, W10x49s? The answer is yes. Okay. For instance, when I looked, that example that I looked at previously, that the W10x9 was $60 a foot. What if that $60 a foot did not come from 2019 data? What if that came from data that I found 20 years ago? Would that data be usable today? The answer is yes, with appropriate cost indexing. So what specifically is a cost index? A cost index is a ratio of the cost of goods essentially from one condition to another. And right now I'm looking at cost indices as a function of time. Okay? So there are resources at RSMeans, even the book that you're passing around now has cost indices as a function of time. They're also available online. I have a link to them as well. But essentially the way it works is that if you have the cost of something in a previous period of time, and you want to know, well, how much does that cost today? What you would do is you would multiply it by the ratio of cost indices from the current period of time to the previous period of time. It's a pretty straightforward computation. So here are some historical cost indices. So let's say, for the sake of discussion, that data that I presented, the cost of the W10x49, remember the W10x49 was what, $60 a foot? Well, let's say that's $60 a foot, and I'm just using this for an example, but let's say that $60 a foot was from data reported in 1985. Like, that's how much the W10x49 cost back in 1985. I say, well, that's how much it cost in 1985. How much does it cost, let's say, in 2016? Well, what I would do is I would take that $60 a foot and I'd multiply it by the ratio of these cost indices. So I'd say, okay, $60 a foot times, let's say, 100 divided by, 39.9. Okay, and so that would tell you, on the whole, how much more expensive that would be. And if you think 100 divided by 39.9, that's bigger than 1, which means that an item in 1985 is going to cost less than an item does in 2016 because the ratio is going to be bigger than 1. That make sense? Pretty straightforward. Okay, so it's pretty straightforward to take a resource, even if you have an RSMeans guide that's 5, 6, 7 years old. That doesn't mean it's not useful. That just means you have to index it appropriately. Okay. Now, it also should be noted that we can also index things as a function of, yes. What's that? Well, I'm going to, yes, and I'm going to talk about specific types of products actually here in a second. So, that's true. I do see what you're saying. Let me make a point on that, because you are making a good point. The idea that if you're talking about a product where the price is volatile and it can change a little bit, I would say in real world cost estimation, I probably wouldn't use cost data from the 60s if I could use cost data from 3 or 4 years ago. Now, that being said, cost data from 3 or 4 years ago is fine as long as it's properly indexed. Another point I guess I would mention, and we're going to talk about this here at the end, but let's take the project last year. The project last year was looking at a building project, and we're talking about a project where just the structure was something like $5-6 million. Okay, and I would get estimates from students that would say this project will cost $5,186,243.97. Really? Yeah, and I get what was happening. What was happening is they were breaking out the Excel. The Excel was computing the numbers for them. They said, well, that's what Excel said. Well, I understand that's what Excel said, but let's use some common sense. Keep in mind, We are estimating, So if you have a project that's, going to be a $50 million project, you are not good enough to estimate that project to the penny. You just aren't, okay? I don't care how smart you are. You're not that good, and if you are, you wouldn't be estimating construction projects. You'd be buying Powerball tickets. So that's just the facts. So the point I'm making is I wouldn't use data from the 60s. I'd probably use data that's at least somewhat in the near time period. And as long as you recognize it's an estimate, you're going to be fine. Now, when we look at city indices here in a second, there are differences between the industry. But yes? Well, you're raising an excellent example, and I think all that would change is maybe just some of your quantities. The actual, maybe the size of the field, the distance between bases, the total amount of earthwork that needs to be done just because of the site. But in the end, I would argue that the construction methods for constructing a baseball field or constructing a softball field are going to be the same. It's just going to be a little different. Now, if they just built this, let's say 2 or 3 years ago, and then they're coming in and building a baseball field, well, I mean, 2 or 3 years, the costs are going to change a little bit, but not drastically. Now, if it was 40 years ago, well, things change. Yeah, I do. Because whenever you build a project, once you build the next one, if it's very similar, you're going to do better at it. One of the common comments that I always get from students in here is, well, what if you could go back in a time machine in January and do this again? The first response is, oh, hell no. But the second response is, well, if I had to do it again, I would do things a lot differently, and the project would get done a lot faster because you've been through it once. So there is something to be said about, you're going to continuously improve upon your process because you've done it before. Now, if you're embarking on a project that you or nobody else has ever done before, there's going to be a learning curve. I mean, to say there isn't is a lie. So that's good. That's a good point. Any other questions? This is good stuff. All right. Okay. Now, historical cost indices, like I said, are really trying to normalize your prices and get them back to a proper time period. Whereas one of the things that he noted was, well, things in Huntington, West Virginia just don't cost the same amount as things in Manhattan. This is not the same story, okay? And that's true, okay? Now, what is being reported in RSMeans is sort of what I'm calling a national average, but basically it's taking data from 30 major U.S. cities, and those cities are listed here. So the prices that you're seeing in that guide are prices averaged from places like Detroit and Indianapolis and Seattle and Pittsburgh and Milwaukee, and all of those 30 cities are averaged to produce the prices that you see in that manual. Well, that doesn't really help you out if you're in Huntington, West Virginia. So how do you normalize those prices to Huntington, West Virginia? Well, it's the same process. You would normalize city costs. You take the ratio of the city cost index for your location divided by the city cost index for the national average. Now, the national average city cost index is usually based off 100, so the computation is pretty easy. So I have here some city cost indices. I found these online from 2013, so they're good enough for our purposes, and I have a link to that as well. And so when you pull up the city cost index table, there's oodles and oodles of tables. Like for just the state of West Virginia, I believe there's like 15 different locations. So we've got, like here's West Virginia. We have Gassaway, we have Huntington, we have Lewisburg, we have Martinsburg, we have Morgantown. And I think there's like 15 different cities that are listed. So for Huntington, here you can see the different indices. Now, again, the national average is all based off 100, and this is sort of, I think, going to what you were talking about. So for instance, if we're looking at metals, the cost indices are a little bit lower. Whereas if you're looking at thermal and moisture protection, the actual material costs are a little bit higher. The installation costs are a little bit lower, but that's dependent. For some reason, flooring is a little more expensive in Huntington. For some reason, let's see what else. Openings in structures are a lot cheaper. So, it just depends on where you're at. So, if we're looking at metals, and I'm highlighting metals because our example in the slide was looking at a W10 by 49, our cost index for the material would be 97.8. So going back to that example, if our unit price for the W10 by 49, that's $60 per foot, what if it was based off the national average in 1985? How much would that cost in 2016 in Huntington, West Virginia? Well, the historical cost indices are 139.9. The city cost indices are 197.8. So that's $720 in 1985 as an average in the United States. Today, in Huntington, would cost about $1,761.81. Okay, so does that make sense? Everybody okay with that? Now, one final note, just to keep in mind, this is an estimate, okay? It's a guess, all right? Things happen. Prices vary, It's a guess, all right? So $1,764.81 is probably not a level of accuracy that we can rely on. But what I like to think of this is in terms of scale. For instance, if you buy a bathroom scale to measure, your weight, all right? Well, let's say that bathroom scale has, a capacity, but the accuracy might be plus or minus, I don't know, 1/10 of a pound, okay? Whereas if you buy a laboratory scale that's supposed to measure precision small quantities of laboratory samples, its accuracy might be plus or minus 10,000ths of a pound, The accuracy depends on what you're talking about. If you're weighing, if you have a scale that's supposed to weigh trucks on the road to make sure they're following the weight postings, well, do you think that scale is going to be accurate to plus or minus the 1,000th of a pound? No, that scale is meant to weigh, tonnage. It's going to be accurate to plus or minus 100 pounds or something. So I think the accuracy and what you can hang your hat on is dependent upon the scale. For instance, we computed $1,764. I think that if we're talking about estimates in the $1,000 range, we can probably be accurate to plus or minus maybe 25 bucks. So I don't think that we can hang our hat on this, but I think that's a pretty reasonable estimate to say round it up to the nearest $25 and say $1,775. That's a pretty good estimate, okay? Again, it's an estimate. You could round that up and say, it's $1,800, probably. I mean, I wouldn't round it up and say, let's call it $10,000, but I mean, be reasonable with it is all I'm saying. Be engineers. This is where engineering differs from mathematics, I think, a little bit. So, a little bit of the common sense and using your gut a little bit. Any questions? I do want to show you something else. I pulled this up on, or I posted this on Blackboard. Now, this book that you're passing around, if you look in the back of the book, like I said, you will see crews. You'll see work crews, okay? Now, I have here crew E2, okay? Now, if you look at the crews list different workers and equipment based on the type of installation that's being done. So let's look at this work crew. It's a structural steel foreman, 4 structural steel workers, an equipment operator, an equipment maintenance personnel, and a 90-ton crane. Take a wild guess what this crew is doing. I don't think they're doing bricklaying, That's an iron worker crew. That's a crew doing structural steel erection, okay? So if we're talking about a W10 by 49 or what have you that's so many feet and so long, this is the crew that would most likely put it together, right? Make sense? So I have here just some basic cost information. So over here on this sort of next table, this table that you see right here, this comes, let's see. This comes from this. So I looked up how much does, let's say, a W14 by 74 cost. So W14 by 74 costs $91.50 per linear foot. The labor is $2.70. Equipment's $165. Particularly for this column, what we're looking at is just that we're looking at a column. That's another thing to keep in mind, is that the erection of a column and the costs associated with erecting a column are going to be different than the costs associated with erecting a beam. It's not the same story. It's not erected the same way. It's not connected the same way. So let's say I have a W14 by 74, and I want to know what the cost for erecting 24 feet of that column would be if the overhead rate was 10%. And I'm not going to sit here and go through every single nitpicky detail because it's actually listed right here. Everybody in here has access to this spreadsheet. I almost want to make you look at it yourself, you know. Like, shucks, I'm making you do some work on your own. Who the hell do I think I am, you know? But what you see here is just a breakdown of the cost estimate. Now, these costs are listed in 2011 dollars, and so over here on the right, you can see me indexing it to 2016 and indexing it to Huntington, West Virginia. And so you can see how I, calculated a cost of $2,610.59 and then rounding it to $2,625 just to keep it, reasonable. Now I'm talking about one element in a structure. In all honesty, if we were talking about a whole building, we'd be talking about, millions of dollars, and I'd probably round it to the nearest, 10,000 or 100,000 or something like that. But yes. That's possible, and it also depends on what we're talking about. For instance, if we're looking at a bridge, then costing the girders per linear foot makes sense, but costing the deck per square foot as a function of area can make sense in that regard as well. It just depends on what you're looking at. It's not that uncommon in the bridge sector to just express costs of bridges in general as cost per square foot. That's very common. So for instance, if you have a bridge that's 40 foot long and 24 foot wide, how much does that bridge cost per square foot? That's very common expression in the bridge industry. Then it just depends on what you're looking at. Route or linear type projects, expressing them in linear feet can make sense, but area and earthwork projects, expressing those in square feet, makes sense as well. Mm-hmm. That's a good question. That's a good question. This is going to be the best answer I can give you. And again, don't be frustrated if I don't give you a yes or no answer. Let's say you have two alternatives, steel bridge and a concrete bridge. I want to see cost estimation on both. It does not need to be this super fine detailed, but I need to see some justification that you picked one versus the other. And it may be more in the alternatives. Because look at it this way. If you present to me, okay, here's our steel bridge, here's our concrete bridge, we went with the concrete bridge. Why? Because we flipped a coin? I'm not saying that to be facetious. I'm being serious. There has to be a reason why you went with steel versus concrete. So in the alternatives phase, what I'm saying is this. I want you to be able to defend your reasoning. You take the cost estimate as far as you think you need to go in order to do that. And let me give you an example of that. These cost indices and cost data, they go down. If you look at the cost of, let's say, just a W14 by 74, if you look in the manual just says, here's how much it costs with labor, overhead, profit, and everything. And you could use that for your alternatives phase. But when you get to the final phase, then I want to see the super detailed one. But maybe that's not enough. Maybe you need to go further. And that's where your internal group has to make the decision. That's where I kind of have to bite my lip. I wish I could give you I actually don't wish I could give you a yes or no answer because I want you to get angry.
The cost estimates for like the dollars per linear foot, does that take into account like the little things like nuts and bolts that like put everything together, or is that like a separate thing on the item list?
Yeah, the short answer is you need to look. I mean, you honestly need to spend some time pouring through the manual and see. This was what I'm going to say. If I'm the client and you tell me the project costs $200,000, and then you come to me later and you go, we didn't take into account the washers on the bolts, and so I need an extra 20 grand, I'm going to laugh a lot. Anybody who has worked in the consulting world, am I wrong? So you're responsible for it. Whether these values incorporate that data, that's where I'm going to make you look into it. You know, and it's not, here's a perfect example. I've had students, okay, so let's say let's look at the deck, okay, reinforced concrete deck, okay. Okay, the deck's going to be 8 inches thick. We got a mat of number 4 bars and a mat of number 5 bars. Bam. Good. What about the formwork? You're just going to like float it up in the air and cast it? Like, we're going to get one of the X-Men to just... I'm being facetious, but in all seriousness, it's more. Honestly, it's even more than just the raw cost of the material. I mean, the formwork, you know, and again, equipment costs, labor costs, all that goes into it as well. So you need to produce an estimate that accounts for it all. Whether those numbers account for it all, make you do some digging. My only geotech pun. Digging. Do some digging. It's too easy. Any other questions? I mean, this is good stuff.
When are you going to post all this information?
This is posted.
But like the alternative states and all that.
The report guidelines, that's going to be soon. It's probably going to be the week after next. I mean, the report isn't due till the middle of March. So. If you think it will help, I will post it soon. But I've done this enough to know that as much as I say that you need to get on it soon, what happens is, it's funny, you know, right after my birthday, I get real popular. Because my birthday's on March 1st, and then right after March 1st, the report's due on March 15th. It's like, hey, Dr. Mike, so we got to talk about that report. You've had the report guidelines for a month. Yeah, we know, but it's due in 2 weeks, so now we really started working on it. Everybody's shaking their head, yes, that's a bad thing. I know. I'll probably get you something here within a couple weeks, and I'm hoping to get it done sooner than that. I can tell you this, you will definitely get your report guidelines well before you get your presentation guidelines. Well, don't say that either, because the report is due like on Friday, and then the presentation is that following week. So you do want to make sure you're planning that stuff in tandem. This is a good point. Listen, the main reason why I need time is because we have 6 groups in here, and one of them is an environmental group, so I want to make sure that everything's, you know, copacetic there. So I need time. So. Yep. Don't worry, you'll have plenty of time. What you should be doing right now is, you know, researching just common short span bridge solutions. And I mean, you could do that research on your own, well without report guidelines. Let's talk a little bit about logistics for the next little bit. So Friday, one of the things I'm going to talk about Friday is reporting throughout the semester. So what I want to see on meeting minutes, what I want to see on, you know, timesheets, things like that. So that, because that is coming up. So I'm going to give you some somewhat detailed information on that. I'm going to show you MathCAD in a little bit more of a formal setting so that everybody's aware of how to use it. So if you want to bring your laptops Friday, that actually might not be the worst idea if you have MathCAD installed. So, because I'll show you how to use that. You are?
Yeah, it was.
I'll look into it, and if it comes down to it, and I have to provide like installation, or I'll look into it. I'll look into it. But one way or another, I'll figure out how to get you access to MathCAD Express. I mean, like I said, PTC says they offer it for free, so I know you should get it at some point. But I'll show you formally how to use that on Friday. Then when we get back after next week, we're going to start Bridge Engineering 101, okay? And bridge engineering, just so you are aware, is different than steel design and concrete design. And there is stuff that you haven't seen. So it's going to be new for everybody. I know it's going to be new for everybody. Stop laughing. Don't worry. I'll get you through it. Bridge engineering is the reason I'm Dr. Michelson instead of Mr. Michelson. So it's something I know pretty well. You'll be fine. I promise. We're going to come back to that question later on in the semester, and there is going to be a point where I am going to be able to say, I guess I am an expert, but I'm going to save that for later. I'm going to put that one in my back pocket. All right. That's all I got. See you on Friday.